Let's take a step back and talk about credentials, secrets, and policy types, because this is one of the most important areas for keeping AWS environments secure. At a high level, this topic is about how identities authenticate, how sensitive values are protected, and how permissions are defined and enforced. In AWS, credentials are what allow a user, application, or service to prove who they are. For programmatic access, AWS uses access keys, which consist of an access key ID and a secret access key. These are commonly used by the AWS CLI, SDKs, and automation tools. Because access keys grant direct access to AWS APIs, they are extremely sensitive. Best practice is to rotate them regularly, never hard-code them into source code, and, whenever possible, avoid long-term access keys entirely by using IAM roles with temporary credentials. For console access, users authenticate with a username and password. AWS allows you to enforce password policies to improve security, such as minimum length, complexity requirements, password rotation, and preventing password reuse. On top of that, multi-factor authentication, MFA, should always be enabled for human users, especially for privileged users and the root account. Credentials aren't the only sensitive data you need to protect. Applications also rely on secrets such as database passwords, API tokens, encryption keys, and OAuth credentials. AWS provides managed services to store and protect these values securely instead of placing them in code or configuration files. AWS Secrets Manager is designed specifically for managing secrets. It securely stores secrets, integrates with AWS services, supports automatic rotation, and provides fine-grained access control using IAM. This is ideal for things like database credentials or third-party API keys that need regular rotation. AWS Systems Manager Parameter Store is another option for storing configuration values. It supports secure string parameters, which are encrypted using AWS KMS. Parameter Store is often used for application configuration and simpler secrets when full rotation features aren't required. The key idea here is simple. Never store secrets in plain text or source control. Always use a managed secret service. Finally, let's talk about policies, which define what actions are allowed or denied in AWS. AWS supports several types of policies. AWS managed policies are pre-built and maintained by AWS. They're easy to use and helpful for common use cases, but they can be broader than necessary. Customer-managed policies are created and maintained by you. They are reusable, versioned, and ideal for implementing least privilege at scale. This is the recommended approach for most production environments. Inline policies are embedded directly into a single user, group, or role. Because they are tightly coupled to one identity and harder to manage, they should be used sparingly. Regardless of the policy type, the goal is always the same. Grant only the permissions that are required, nothing more. Credentials authenticate identities, secrets protect sensitive values, and policies control permissions. When used together correctly, strong authentication, secure secret storage, and least privilege policies, they form the foundation of a secure AWS access management strategy. This is how you reduce risk, prevent accidental exposure, and build secure systems that scale.
Alright, so at this point, go ahead and pause the video. Take a moment to read the question carefully, and try to answer it on your own. Once you've made your choice, resume the video. Next, I'll walk you through a few clues to help you identify the correct answer.
Here are a few clues to guide you. The question explicitly mentioned short-lived credentials, not long-term ones. AWS best practices strongly recommend avoiding stored access keys on EC2 instances. Think about how AWS allows services to assume permissions automatically without embedding secrets. Ask yourself, which option integrates natively with EC2 and automatically rotates credentials behind the scenes? Also consider which approach aligns with the principle of least privilege and minimizes operational risk. Keep these points in mind as you review the options. In the next slide, we'll reveal the correct answer and explain why it's the best practice. The correct answer is, create an IAM role and attach it to the EC2 instance. This is the correct choice because IAM roles provide temporary, automatically rotated credentials to the EC2 instance without storing access keys anywhere in the code, configuration files, or environment variables. AWS securely delivers these credentials through the instance metadata service, following the principle of least privilege and significantly reducing the risk of credential leakage. The other options are not recommended because they involve storing long-term access keys, whether in environment variables, plain text configuration, or hard-coded in the application, all of which increase the risk of accidental exposure and violate AWS security best practices. When we talk about authentication in AWS, we're answering a simple question: who are you, and how does AWS verify that? AWS supports multiple authentication methods because different users, applications, and environments have very different needs. 1. IAM user credentials. We'll start with the most basic form of authentication. Username and password are used by IAM users to sign in to the AWS Management Console. This is common for human users who manage AWS resources. Because these credentials are powerful, AWS strongly recommends enforcing strong password policies and always enabling multi-factor authentication, MFA, to reduce the risk of account compromise. Access keys, made up of an access key ID and secret access key, are used for programmatic access, such as through the AWS CLI SDKs or APIs. These keys should never be hard-coded, shared, or stored in plain text. If access keys are leaked, attackers can act as that user. This is why AWS encourages minimizing their use and replacing them with roles whenever possible. 2. Multi-factor authentication, MFA. MFA adds a critical extra layer of security. In addition to a password, users must provide a second factor, such as a code from a virtual MFA app, a hardware token, or a FIDO security key. Even if credentials are stolen, MFA makes it extremely difficult for attackers to gain access. This is especially important for privileged users, like administrators and the root account. 3. Federated authentication. Federated authentication allows users to sign in to AWS using existing corporate or external identities, instead of creating separate IAM users. With SAML 2.0 federation, organizations can authenticate users through systems like Okta, Azure Active Directory, or on-premises Active Directory. This is common for enterprise environments. OIDIC federation is widely used by web and mobile applications, allowing users to authenticate through trusted identity providers using modern OAuth and OpenID Connect flows. AWS IAM Identity Center brings this together by centralizing workforce access across multiple AWS accounts and applications, making it easier to manage permissions, single sign-on, and identity sources in one place. 4. Temporary security credentials. Temporary credentials are a cornerstone of AWS security best practices. IAM roles provide short-lived credentials to applications, AWS services, or users who assume a role. These credentials are automatically rotated and expire, eliminating the need for long-term secrets. AWS Security Token Service (STS) is what issues these temporary credentials. STS enables scenarios like cross-account access, federation, and secure role assumption, all without storing permanent access keys. 5. Additional authentication methods. AWS also supports specialized authentication mechanisms. Amazon Cognito for user authentication in web and mobile applications. Mutual TLS, MTLS, for certificate-based authentication between systems. IAM Roles Anywhere, which allows workloads running outside AWS, such as on-premises servers, to securely assume IAM roles. AWS offers multiple authentication methods because security isn't one-size-fits-all. The key idea is to use the most secure option for each scenario, favor temporary credentials over long-term ones, enable MFA wherever possible, and integrate with existing identity systems when appropriate. Understanding these options is essential not only for passing the exam, but for designing secure AWS environments in the real world.
Alright, so at this point, go ahead and pause the video. Take a moment to read the question carefully, and try to answer it on your own. Once you've made your choice, resume the video. Next, I'll walk you through a few clues to help you identify the correct answer.
Before revealing the correct answer, here are a few guiding clues to help you reason through this question. The company wants employees to use existing corporate credentials, not create new AWS-specific users. The identity provider mentioned is Microsoft Azure AD, which is an external identity system. This is a workforce authentication scenario, not application-level authentication. AWS supports trusting external identity providers through federation, instead of managing passwords in IAM. Look for an option that avoids long-term credentials and avoids IAM user sprawl across multiple AWS accounts. Keep these points in mind as you review the options, then we'll reveal the correct answer in the next slide. The correct answer is, use SAML 2.0 federation to authenticate through the corporate identity provider. This is the correct choice because SAML federation allows AWS to trust an external identity provider like Microsoft Azure AD. Employees sign in using their existing corporate credentials, and AWS grants them temporary access through assumed roles. No IAM users or passwords are created in AWS. Why the others are incorrect? Creating IAM users and sharing passwords is insecure and not scalable. Long-term access keys are not meant for human authentication. API gateway authorizers are for application access, not workforce login. SAML Federation is the AWS best practice for centralized, secure workforce authentication using existing corporate identity systems. Let's walk through this slide together. First, IAM users. IAM users represent individual people or applications that need to interact directly with AWS. Each user has their own identity and credentials, which makes activity traceable and auditable. From a security perspective, the most important rule here is least privilege. That means you should only give a user the exact permissions they need to do their job, nothing more. Broad permissions like administrator access should be avoided for daily work and only used temporarily, with clear justification and auditing. This reduces risk if credentials are ever compromised and helps keep environments secure and controlled. Now, IAM groups. IAM groups are used to organize users by job function, such as developers, security auditors, or database administrators. Instead of assigning permissions to each user one by one, you attach policies to the group and then add users to it. This approach is more secure, consistent, and scalable. When someone joins or changes roles, you simply update their group membership instead of rewriting policies. From a least privilege standpoint, each group should have only the permissions required for that specific role. No extra access. Now let's talk about policies, which are the core mechanism that actually defines what users, groups, and roles are allowed to do in AWS. First, customer-managed, custom, policies. These are policies that you create and maintain yourself, and they give you the highest level of control. With custom policies, you can be extremely precise about which actions are allowed, on which resources, and under what conditions. This is the best way to truly implement the principle of least privilege. For example, instead of allowing full access to Amazon S3 with something like S3, you can allow only the exact action required, such as S3:get object. You can also restrict access to specific resources by targeting exact ARNs rather than entire services. On top of that, IAM conditions let you add powerful safeguards, such as allowing access only from certain IP addresses, requiring MFA, or limiting actions to specific times or regions. Custom policies should not be set and forget. Over time, roles change and applications evolve, so it's important to review and refine these policies regularly, removing permissions that are no longer used to reduce security risk. Now, AWS Managed Policies. AWS Managed Policies are pre-built and maintained by AWS to cover common use cases and job roles. They're very convenient, especially when you're getting started or need to quickly enable access for a standard task. However, because they're designed to work for many customers, they're often broader than what a specific environment actually needs. When using AWS Managed Policies, it's best to choose the most restrictive option available. For example, using read-only access instead of a full access policy whenever possible. As your environment matures, you should gradually move away from AWS Managed Policies and replace them with customer-managed policies that better match your real requirements. In more advanced setups, permission boundaries can also be used to limit how much access a user or role can ever receive, even if someone attaches a broader policy by mistake. The big takeaway is this: AWS Managed Policies are great for speed and convenience, but customer-managed policies are essential for strong security. To achieve least privilege at scale, rely on custom policies, review them regularly, and use AWS Managed Policies only where they truly make sense.
Alright, so at this point, go ahead and pause the video. Take a moment to read the question carefully, and try to answer it on your own. Once you've made your choice, resume the video. Next, I'll walk you through a few clues to help you identify the correct answer.
Before choosing an answer, pause for a moment and think about what the goal really is. Clues to guide your thinking. The requirement is read-only access, not full control. Access must be limited to one specific S3 bucket, not all S3 resources. The question explicitly mentions the principle of least privilege, which means only the minimum permissions needed, only on the required resource, assigned in a scalable and manageable way, not per user manually. Now look at the options and ask yourself, which option avoids broad permissions? Which option avoids using the root user? Which option is reusable and aligned with IAM best practices? The correct answer is, create a custom policy allowing only S3:get object on the specific bucket and attach it to a developer group. Why this is correct? This approach follows least privilege perfectly. It grants only read access, S3:get object. It restricts access to one specific S3 bucket. It is attached to a group, making it scalable and easy to manage. It avoids overly broad permissions and unnecessary risk. While the other options are wrong, Amazon's full access grants far more permissions than required. Using the root user is unsafe and violates AWS security best practices. Administrator access completely breaks least privilege by granting full control.
Thank you for watching. See you in the next class.